Good morning, ladies and gentlemen. Welcome to Unit 8 of Microcontrollers. My name is Tursunak Aslan and I am working in the Department of Computer Engineering in Harran University as a faculty member. Today we are going to focus on the interrupt operation on microcontrollers. Let's begin. What is interrupt operation in microcontrollers? As we know, we are using assembly language to program our microcontrollers. Assembly codes that are being processed in microcontrollers might be stopped and called subprogram. While the microprocessor is busy with the main program, subprogram might be called when there be an emergency situation. For instance, think about when you are playing a game on your mobile phone. When suddenly your friend calls you to your phone, what happens? That means an interrupt operation is happening in your daily life. In microcontrollers, there are four types interrupt sources. The first one is called external RB0 INT interrupt. The second one is timer 0 timer overflow interrupt. And third one is port B interrupt on change, and the final one is data EPROM write complete. In this lecture we are going to focus on the first one, which is external pin interrupt source. What is it? What is external RB0 int interrupt pin? Port B is used as a bi-directional input and output port. The RB0 INT pin can also be selected as an external interrupt pin. In this case, the stack allows interrupts to happen because it contains the return address in program execution. How can we apply the external pin interruption in our microcontroller? We have to follow the 5 stages. The first one is the RB0 is assigned as an output. As you know, we usually assign the RB, that means port B, as output, but in this case we are going to assign as input rather than output. In the second stage, we going to change the bit which is called int edge bit in option register is enable or disable. For example, that means in this case we are going to use falling edge of external pin. That means in the option register we have to change the value of int edge bit to 0. This is the second step. Let's look at the third stage. As you know, INTCON Register has 8 bits. And the seventh is called Global Interrupt Enable bit. Also, we should enable it for all interrupts. That means for the permission in microcontroller for interrupt operation, we have to enable this bit. As we mentioned, there are 4 types of interrupt sources in microcontroller. That means in the first stages, we have to select which type of interrupt sources we are going to use with our microcontroller. In our case, we have to select the external bit interruption. That means the int enable bit in INTCON register should be enabled for the external interrupt pin. And finally, we have to change the value of the int f bit INTCON register because it will be 1 after the interruption. We should allow the microcontroller to call the subprogram again and again. That means every time the interruption is ended, we should change the value of int f bit to 0. Let's look at in details. Let's focus on option register. What is it? Normally, the option register is a readable and writable register which contains various control bits. In our case, to configure the external int interrupts. As you see, there are 8 bits in option register, but in our case, we are interested in the 6th of the option register. That means int edge. This stands for interrupt edge select bit. It is used to interrupt on rising or falling edge or RB external bit. That means if you want to select rising edge, that means you should make it 1 or 0. But what is falling or rising edge? For example, just think about the button control. For example, for the button control, we need resistors and switch. For example, let's look at the first figure. Can you see? We have 5 voltage, but there's a switch here. That means we can't apply high voltage to microcontroller. That means we are applying low value to microcontroller. But when we press the button, that means when switch on, can you see we are applying high value. That means this button is used for raising edge. That means because the value which is applied to microcontroller is changing from 0 to 1. But what about the figure 2? As you see, we are applying 5 voltage to microcontroller directly. But when we press the button or when we switched on, can you see we are applying low value to microcontroller. That means this type of connection is used for falling edge rather than rising edge. Also, let's look at here rising and falling edge. Can you see from low value to high value, this edge is called rising edge. But in this case, from high value to low value, to change the value from high to low, we call this edge as a falling edge. This is happening, especially signals is called square wave is type of rising and falling edge because it is happening continuously. What about INTCON register? The INTCON register is a readable and writable register that contains the various enable bits for all interrupt sources. As you see, there are 8 bits INTCON register, but we are interested, first of all, with the 7th of the register. For example, GIE stands for Global Interrupt Enable Bit, and it is used to enable or disable all interrupts. That means for the microcontroller to call subprograms, first of all, we have to allow the microcontroller for interrupt operation. And then let's look at the int E bit. That means it stands for RB0 external interrupt enable bit. This bit is used to enable or disable the RB external interrupt. That means after allowing the interrupt operation, we have to select which type of interrupt sources we are going to use. That means in our case, we have to enable this bit. And finally, after our interrupt operation is called, that means if you want to use microcontroller to enable the interrupt again, that means this int f bit, that means should be the value in this bit should be 0 again for the happening interrupt operation. This is our template or program template. We are going to start in the first line. That means after that we are going to call the start, the main program. That means the for line of the program memory is not called yet. Whenever you call the start label, that means your main program is started. But when the interrupt is happening, that means you call the fourth line of the memory. That means it is connected to interrupt subprogram. After your subprogram is carried out, that means you should return to do main program again. This is the template. Now let's look at our program. This is our program for the interrupt operation in microcontrollers. First of all, we have to list which microcontroller we are going to use in our program. That means 16F84A in our case. After that, we are going to include the library to utilize default labels such as port A, such as port B. This is default labels. After that, we are going to start our program on the 0 line of the program memory. After that, we are calling the main program. That means this line is not called yet. This is our main program. Can you see? At the beginning of the program, we are just clear port A and port B. That means if any LED or output is connected to our microcontroller, that means LEDs will be turned off. After that, by using BSF, that means bit set file, we are setting the value of this fifth bit of the state register to 1 to change the bunks from 0 to 1. Can you see here? After that, we are clearing trace A register. That means all the values in the trace A register will be 0. That means port A will be used as outputs. And then we are uploading FF in hexadecimal number. That means 255 in decimal number system. We are uploading this number to W register. After from W register we are writing the value to trace B. That means we are going to use port B as inputs rather than outputs. Why we are using port B as inputs rather than outputs? Because just let's go over lecture again. Because we have to follow 5 stages in here. Remember, the first one is saying the RB0 interrupt pin should be assigned as an input rather than output. Okay, just input. This is the first stage. That's why we are doing. Let's look at our program again. After that, still we are in bank 1. We are using BCF command to change the value of the 6th bit of the option register to 0. Why we are doing this? Because we are going to use falling edge for the interrupt operation. After that, we can go to the bank 0 by changing the fifth of the status register to 0. Okay, we assign the value RB0 to input as an input, and we selected falling edge. And now in this line, we are going to allow microcontroller for the interrupt operation, because this is GIA bit, that means it will be 1, and this is also used to select which type of the interrupt sources we are going to use. That means in this case we are going to use external pin operation. And then our program starts. Can you see this is a button control command on condition? That means we are checking the value of the first bit in the port B register. If it is 0 or if it is 1, for example, because this is clear, that means we are checking if it is 0 or not. If it is 0, that means this line will be skipped. That means port A, the LED, possibly it is LED, the LED is connected to port A will be turned off because we are using BCF command. But if in this case, if the first bit of the port B is not 0, that means these two lines will run forever. That means someone should press the button in our case. After the turning the port A, first bit of the port A bit to off, that means we are going to call the start label again and again. That means this part, this main program, just checking the port B and turning the LED off. That's it. What about interrupt program? This is sub-program rather than main program. That means we are going to turn the first bit of the port A. Can you see? This lets the port A off, but this lets the port A on. Can you see? After that, because the interrupt operation is called from the microcontroller, that means we should reactivate the interrupt again. Can you see? That's why we clear the first bit of the INTCON register. After that, by using return from interrupt command, this stands for return from interrupt commands, to the line we just called the interrupt function. That means we continue to our main program. This is it. Let's save it and run the compiler. Can you see there is no error? And now let's go to our simulation. This is our circuit. Can you see? Let's just examine. Can you see a LED? And I think green. Yeah, a green LED is connected to microcontroller, the first pin of port A. Can you see? Okay. And we have also two buttons. Can you see? One is connected, the first button is connected, the first pin of port B. And second button is connected to port to the pin 0 of the port B. Can you see? But can you see we are applying high value to these pins? That means the value in these pins is 1, not 0. But when you press the button, the value you are applying to microcontroller will be 0. because of the ground. Okay, now let's upload our program. This is our program. Let's run it. Okay, can you see? The red color means you are applying high voltage to the pins, but blue colors means you are applying low value to pins. Let's start. If I press this button, nothing happens. Why? Just look at our program again. Just let me set my screen. Okay. In here, this is important because yeah, this is important. Let's focus on here. Okay. Can you see in the start section of the program? Can you see we are controlling the button? That means we are controlling the first bit of the port B. Find out whether it is 0 or not. Can you see? It is 1. That means the go to start line will not be skipped. But when you press the button, this line will be skipped and the first pin of port A, that means our LED, will be turned off. But by default, it is already turned off. That means nothing happening. But when I press this second button, can you see what happened? Can you see? LED is on now. Why? Because whenever you press the second button, that means an interrupt operation is called from the microcontroller. This is our interrupt program section. Can you see? Port A, first bit of the port A is set on. That means LED is on now. But and then this is our that means we are going to call the interruption again in this line. But now is LED is on. Now interrupt program is finished, and now we are in the start program. Can you see? We are checking now. Checking the program. Can you see if it is 0 or not? But because it is not pressed yet, but when I press, that means this line is skipped and this line will be called run. Can you see? And LED will be off. Let's try. I pressed button. Can you see? LED is off now. That means I'm in the start, and then now I'm calling, checking continuously the value of the first pin in the port B. Can you see? Okay. This is the way we can call an interrupt. We can call the interrupt or subprogram. This is the first type of interrupt sources in microcontrollers. For example, if you not allow this one, for example, if you put this one instead of BCF, that means you are not allowing the microcontrollers for the interrupt operations. Let's run it and see what's happening. I just compiled. Successful. Again, I am uploading an extra code. Okay, this is our program. If I press this button, control just is can you see LED is on? But if I press button is off, that means global interruption pin still running. Can you see? Let's change this value. Instead of 4, let's use BCF and see what happening. Okay, I run it. I just press this button again. Can you see that is on? That is off. Can you see? But let me check again because this is our simulation. Let's upload our microcontrollers. Here we are in the wrong places. I'm uploading the real codes. Okay, running again. Can you see? Nothing happening. Because let's go again. Let's make it this set again. Let's compile. Okay, let's upload again. Now it's running. Can you see? Let's go to our code again. Let's change this to BCF. Make sure it is 0. That means uh, I'm not allowing the interrupt operation on microcontrollers. Let's compile and run again. Okay, I just press the my interrupt button. Can you see? Nothing happening. That means still we are in main program. No interrupt, no sub program is called. Okay, let's allow the global interrupt, but let's stop the external pin interruption. Let's compile. Okay, let's run it. Now the microcontroller is enabled for the interrupt operation, but we didn't enable the first type of external pin operation. Okay, let's run it. Can you see? No, that is running. That is not on yet because we didn't allow the microcontroller to enable the external pin interrupt. Can you see? Let's go again and change the value. It's set file and compile. Run it. Can you see now? That is on because interrupt is happening. That means in assembly language, whatever you write your program, whatever you write on your program, it will be implemented line by line. This is the low level program assembly, but which is very close to machine languages. Okay, next time we are going to implement this interrupt operation in real circuits.